this on? Yes, it is. So, I've heard a set of pretty fantastic talks this morning, all of them almost aspirational and positive about both where we're at and where we're headed. I'm going to be a little bit more geeky, though, on what I have to present over the next 20 minutes, and perhaps it's not even a presentation, perhaps this is just a therapy session of most of my problems in designing this intelligent agent, and you're not really participants, but I'll certainly walk away a little bit healthier. And if so, then I'm happy. If we're lucky, then you'll walk away having certainly some understanding of some of the challenges that comes along with trying to bring one of these intelligent agents to life. So quickly, just before we start, my name is Dennis. I'm the CEO and founder of a company called X.ai. We are based out of New York. I'm obviously not from there, but the whole team is there, and we spent the last good 4 years trying to kind of engineer this agent that can schedule meetings on your behalf. Something which sounds overly simple, as in, how hard can it be to get two people together next Wednesday at 1? You don't need any fucking AI for that, just ring him. But it turned out to be way more complex, certainly, than what we've imagined. And the team is about, all in all, 130 people, just to give you some perspective on the amount of effort that we've applied to it. The one thing that I'm going to talk about is this new class of what we call perceived errors. And I tell you, those are the ones that certainly hurt the most. And we'll get into exactly why that is. So just before we jump into it, and I'll use some kind of real life examples, let me just explain exactly how our agent works today. So you shoot me an email, right, and say, hey, Dennis, I'm going to be in Manhattan first week of August. Do you got time to meet up for a Diet Coke? Or some version of that. I reply back and say, yeah, you don't look overly crazy. I'm up for that. I've CC'd in Amy, and she can help put something on my calendar. It is now Amy's job, or Andrew's job, our two agents, to understand exactly what they ask the agent to do for me, remove me from the conversation, reach out to one or more participants, have these very human-like negotiations, really, back and forth, drive them not round in circles, but towards a conclusion, understand once concluded, and upon conclusion, craft an invite and send that to both of us. And it's not that this is rocket science. We all do this all the time, every day. Hell, I even did the kind of sad thing of counting all my meetings the year before we started the company. And I did 1,019 meetings in the year 2012. What was even sadder, I had 672 reschedules. What a bunch of fuckers, huh? I spent so much time in setting up all these meetings, then you go about just rescheduling a meeting on me? Not cool. But that's the product. And again, easy to understand, just as it's super easy to understand that we would want cars to drive themselves, but obviously extremely complex to kind of figure out how to do that. So now, in the kind of traditional set of interfaces that we've been exposed to, right? I'm sadly getting older, so I can remember me taking my CS degree mostly on the command line, right? For where if you needed to do anything, you needed to have some sort of education that kind of prepared you for that. And if you couldn't figure out the syntax, there would be kind of immediate response back that either it wasn't the right command or it was a misuse of it. And that was how we kind of communicated with any access to compute at that time. Then later on, we ended up with a graphical user interface. Most office workers with little knowledge could get access to compute, and we designed all sorts of rules around that for what would be good applications and not so good applications. And I think we've reached this point where most of us have a reasonably good understanding of what to expect if we use any kind of visual application, whether that be on our desktop or on our mobile phones. So if I jump into Photoshop and I want to crop an image, and I use that particular feature in that application, and you can imagine any other application which you use on a day-to-day basis, whether that be your Salesforce application or some ATS system or what have you. But if I want to crop an image and I pick 400 by 400 pixels, I have a very clear set of expectations on what to expect on the other side of me having tried to crop that image. And if Photoshop comes back with, hey, Dennis, I cropped it so that you have 410 by 410, just in case you need some extra pixels. What? Like, I don't need any pixels. What I need you to do is crop my image at 400 by 400, because that's what I asked you to do. And if it doesn't do that, I would immediately classify that as an error, as in the application didn't do what I asked it to do. Now, in this new setting for where these intelligent agents mostly exist as invisible software, there is no UI, there is no two pixels, no drop-down, no input box, no checkbox. There's just really a dialogue back and forth. What does that then look like? So an error in that setting, certainly as we see it, and I just somehow didn't imagine this when we started. I just assumed that if you ask my agent a question, and I come up with what I certainly believe is qualified answer, at whatever turn in that dialogue, you would accept that. If it was wrong, it would be wrong. We'll make a better prediction next time. But it would be kind of black and white. And that was just not the case. And if you went and took a look at our support tickets today, given our agents are in market, by far the biggest category are not us making mistakes. It is people believing we made a mistake, as in they had a request, but there was some sort of unexpected result. But if I explain it to you, you actually agree that what I thought was a mistake, which I then complained about or voiced some concern about, having it explained, I now also agree it is the right answer, but it's actually exactly what I wanted. That's an interesting kind of territory to be in, which is that I don't want to change anything about my agent, but somehow when I do exposure to my result, you immediately look at it and say, that's just not right. I'll show you some examples. And this is something for where I find it very hard to believe that anybody doing anything in the intelligent agent space will be able to kind of escape this. And we would probably have to, as an industry, kind of come up with certain design principles for how to make sure that we can bring along humans so they don't sit around with agents that do the right thing, but they think they're moving in the wrong direction. So here's a good example, right? Happens all the time. Use of our agent. I will write, hey Ryan, looking forward to getting together. Like we talked about, Wednesday is my preferred day. Amy will help find us some time. Cheers, Dennis. Seems honest, straightforward. Then Amy will return back and set up a meeting for Thursday. That's now Wednesday. You don't need much machine learning to figure that out. As in, you did the opposite of what I asked you to do, so you must now be at error. And mostly because somehow I get attached to the idea that the machine will be able to execute on my commands as is, without having to take into consideration that there's other constituents in this dialogue, the guest, and for where the guest might actually not be able to fit within the constraints that I put in place. So in this particular example, I did say Wednesday, but Mary was out of town and only available on Thursday, and the agent, certainly as we engineered it, or probably like any human you would have hired to do this job, tried to figure out that having the meeting happen is more important than me sticking to Wednesday. I understand that was your preferred date, but given the new constraint from the guest where they're not even in town until Thursday, I'm going to try to do it as close to Wednesday as possible. Or perhaps, without being kind of too grand, you would call this common sense. And we've tried in many places within our system, which is really, if you think about it, any agent is some sort of natural language understanding challenge, some sort of reasoning challenge, and some sort of NLG challenge. And within that reasoning engine, we certainly tried to implement a very high level of common sense. But common sense is easily understood if I ask one of my fellow co-workers to do a job and they go outside of the constraints which I provided. I just assume something came along and you needed to break those constraints, and I rarely question that. What we see here is that people immediately question that when it's a machine. Now, let's do another one here. I ask Amy to set up a meeting and don't really provide many constraints. And if I don't provide many constraints, like in any other kind of co-worker relationship, I assume you to fall back on a set of defaults, as in, no, I don't like to do meetings at 8 a.m. I would like to get home a little bit early on Fridays. I don't like to do back-to-back meetings. Whatever my set of defaults might be, as in how I want my agent to kind of manage my calendar, if you go outside of those defaults, again, what we've seen is if I set a scheduling hour preference that suggests I shouldn't do meetings earlier than 10 or no later than 5, if I then come back with a meeting at 9 a.m., again, the human will immediately just assume there's a mistake here. Dennis, I'm going to call bullshit. So you raised $40 million to create an AI, and you can't figure out how to do an if-then statement. What the fuck? As in, just go home. And in each one of these, it's been a real endeavor in trying to figure out, say, on scheduling hours, how much elasticity we are allowed to apply to that, and under what circumstances we should allow for that elasticity so that it mimics the idea of common sense. For where if your friend from Hong Kong is in town for one day only, and he's not going to come back until early next year, it is very likely I'd rather break my scheduling hours that seem to be some sort of fixed set of defaults that are there to make sure that I can run week by week within some parameters, but my friend is still only in town for a day, so obviously you should break that. And when we do some of these studies, we can see that people are certainly immediately willing to accept that a human will make that distinction between outside of scheduling hours and willingness to break it and apply that common sense, but they just don't see it when a machine does it. Now, that was the therapy session. That is just me talking about the problems which I have, and you couldn't care less. If you do anything in the intelligent agent space, you should take a mental note of what does your perceived errors look like, as in what people use your system in such a way for where you might think you've sent them upon any level of expectation a good result, but they will still look at it. They might even voice that to you as an error. Now, what we found is that there might need to be some sort of new relationship between, and that's a very grand word, but in lack of any better word, but some sort of new relationship between man and machine, for where there's some sort of rules that put in place if I hire an employee on how we interact with each other. And we don't really need to do too much training on that. That is, I thought you were winking. It's like, I like you too. In that setting, well, we need to kind of create a new relationship. We need to kind of figure out, it probably can't just be one for where I need to go mimic the human-to-human relationship, which is where we started 4 years ago, for where the assistant wouldn't go back and over-communicate. And certainly what we've seen here is that we probably can't survive on just mimicking the human-to-human relationship, and we'll have to come up with a new type of relationship between machine agent and human. And certainly what we've seen here is that when we do things for where your assumption is that this is an error, I should somehow be able to explain why I took a decision. And certainly, if you hired another smart kid right out of school to do a job, and for every task they did, they would come back and say, hey, let me just explain to you my reasoning for having taken this decision. It's like, hey, I think I hired a Muppet. And why do you kind of keep telling me this? I just assumed you were smart enough to kind of figure this out yourself. In this human-to-machine agent relationship, we can certainly see value in doing that. And just in this example here, and I would, had you asked me 3 years ago, suggested that this would not be a good design principle. But if you look at it here, just so you're aware, this meeting time is slightly outside of your regular scheduling hours for calls. Unfortunately, I was unable to find any times within your preferences that work for you and Tanya. If you'd like me to stay within your current hours, I'll speak to that. That's another design principle. Please feel free to send me an alternative time constraint for this meeting. So we're doing two things here. One, we are immediately telling people up front, before they latch onto the idea that this is an error, that, hey, I do know your scheduling hours. I know what you told me half a year ago on how you want me to manage your calendar. I'm also aware of the fact I'm about to break it. So now we're on the same page. That's the first design principle, that you probably had to figure out how far in that kind of vector on over-communicating do you venture. The second one is, whenever you do over-communicate, we certainly found that don't position these as questions, but as conclusions, as in, if you think it's the right action to take, then take the action, but allow for them to change their mind. As in, no, I actually don't want that. He might be coming in from Hong Kong, but he's not my best friend. So we either do it before 5 or we're not meeting at all. And that's fine. So that is certainly one way of having to kind of guard against these perceived errors, for where you are breaking any constraints in your system, go out and communicate about that fact. You can then have all sorts of other systems in place for how often do you do that, when do you think you fully educated the human on this is how the system works, and you might kind of tone down the willingness to kind of over-communicate. And some things you might just over-communicate forever to allow them to kind of bring it back to some setting within their constraints. Now, I'm not overly fond of this because it comes at a cost, right? For where, certainly when I started, I liked the idea of you ask Amy to set up a meeting, anything but her sending the invite, as in any noise between me providing the request and her sending the invite would be a failure. As in, don't ask me about the location, don't ask me about the time, don't ask me about whether he's optional, don't ask me about whether he's in London, don't tell me you're gonna break my kind of scheduling hours, just do your fucking job. As in, that's what I hired you to do. And that is, I think, an attitude that is probably not gonna work, at least for the foreseeable future. There might be a moment for where, just like we remember our kind of early iPhone apps that kind of mimicked a version of the real world, that all disappeared now. That might be the same here. I'll give you one last thing here for where we've certainly seen that another element of trying to kind of guard against this is to expose some of the constraints upfront. This is what you asked me to do. This is the framework within I'm going to take action. I might work within full autonomy, but you kind of know how I'm going to drive forward. And this is your moment to kind of change course a little bit if you want to. That has worked quite well. And actually, by putting the read back in place, we've been able to see that we don't have to do as many explanations, or we can tone them down just a little bit. So there, almost on time. Did I pass? Spot on. Perceived errors is a real thing. If you do design intelligent agents, you should try to kind of figure out what it looks like in your end. Thank you very much. Cheers.
Hey guys, you will have heard from Jürgen earlier, and I just want to let you know, if you are interested in a Meet the Speaker with Jürgen, we have a big sign at the back with a lollipop lady in, there we go, 2 lollipop people with big sticks at the top. If you want to go meet Jürgen, please do go and engage with him for Meet the Speaker. But now it's my pleasure to introduce Dr. Sarah Dillon, who will be talking about Can AI Be Creative? So can I introduce Sarah up to the stage to welcome her panel?
Hello, everybody. Welcome. Isaac Asimov has a great short story that he published in 1976 called The Bicentennial Man, which you may be more familiar with the really, really terrible movie that was made of it. But in it, the robot Andrew astonishes his owner because he produces the most remarkably beautiful wood carvings. A bit more recently, in 2015, Neil Blomkamp's wonderful film Chappie has an AI who starts to learn, and part of his learning journey is learning how to paint. If these stories are to be believed, creativity is what defines us as human, and if it shows that it has it, defines AI as more than machine. But can AI actually be creative, or can it only appear to be so? Why might we want AI to be creative? And what consequences does or could this have, ranging from the philosophical to the technological? And of course, we need to start by figuring out what we mean by creativity anyway. So to help me explore these questions today, I'm delighted to welcome my three panelists. Dennis Mortensen, you've already heard from, is CEO and co-founder of X.ai. We're also joined by David Hanson, CEO and founder of Hanson Robotics, and Professor Maggie Boden, who's a research professor of cognitive science at the University of Sussex and author of The Creative Mind, Myths and Mechanisms. Can we have a round of applause for my panelists, please? And one other thing to draw your attention to before we start the discussion is that I have built a little bit of creative interactivity into this session. So if you wish to take part in this, which will be sprung on you and the panelists at various moments, do get your Slido app up and running on your phone, and you'll see why as we progress. Lovely, thank you very much for coming and joining me today. Maggie, I'd like to start with you. I'm a philosopher by training, so I like to define my terms. So what do we mean by creativity?
I think creativity?
Oh.
Creativity is the ability to come up with ideas in art or science or joking or engineering, which are new, surprising, and valuable. And as far as AI is concerned, the problem is not the new, the problem is the valuable.
Do we have any competing definitions of creativity?
I'll buy that. I think if I were to underline anything for where we're certainly very much on the same page, new is very doable, as in something we can imagine. I think the valuable part is extremely difficult to the point of potentially impossible, certainly for machines alone to figure out whether it's valuable or not.
I think of creativity fundamentally as the existence of new patterns that have some kind of effect. And so the valuable aspect would be defined in a given context. And you could say that, Darwin's natural evolution and the very rules of physics and mathematics would be creative because it generated human beings who are generating valuable things. And you have emergence in nature. So are the seeds of creativity in emergence, or are they in a human-like imagination which can guide the creative process towards a specific useful end to the advantage of humans or some other goal that humans might set? Or is the latter perhaps a more elaborate and complex version of the former, of the physical, mathematical emergence that you have with complexity mathematics?
Well, I would say there's no such thing as the creative process. I would say, there are at least 3 different sorts of creativity, and I think they offer different opportunities and different problems for AI. And one is the one that people always recognize or nearly always mention in their definitions, although neither of you did, but most people do, namely putting familiar ideas together in unfamiliar ways. And many, many examples of creativity are certainly like that. And I mean, even I could probably write a line of code that would do that, get a computer to do that. Making new combinations is not the problem. The problem is making new combinations which we will find interesting or valuable in some way. And of course, the criteria we use will be very different if we're talking about mathematics, or if we're talking about music, or if we're talking about puppetry. So there are all sorts of values that we use, and they change, of course. They change overnight. If you're involved in the fashion industry, you know that very well. So that's combination of creativity, and as I say, the newness is not difficult for AI, but the value is. The second sort of creativity is what I call exploratory creativity, and that, in principle, is much the most possible for AI. Because in exploratory creativity, you start out with a style of thinking, and maybe how to paint, maybe how to write a fugue, whatever. You start out with a style of thinking which is already valued in your community, and you suss out what the rules are, what the constraints are, and you generate new structures within that space. And that's something which AI can do, and that's something which, for example, was responsible for the AlphaGo amazing achievement in terms of comparing the achievement of the AI program with human Go players. So exploratory creativity, we know what the values are, and we manage to somehow build them into the system, and then it follows them, so it's less problematic. But the third sort, and this perhaps, it relates to what you said, is what I call transformational creativity, where you actually change one or more of the rules that define the space so that you can now generate things which were impossible to generate before. And of course, evolutionary AI does precisely that. But the problem with that is, again, that the fitness function, if you like, the value, the judgments of value which are made, by definition, the old ones won't quite do because you've changed the rules. So a decision has to be made about whether or not the newly transformed structures are valuable. And in general, at the moment certainly, a human being has to do that. We don't know how to get the AI to do it because we aren't clear enough about the values that we're using to put them into the system.
And just to kind of latch on to your comment on the whole Google Go endeavor, which was indeed extremely impressive. But if you all seen the movie or the commentary or read the papers, those specific moves that we looked at a later point and kind of suggested were creative in their own right, that was not a machine that defined them as creative or as some sort of output post-game for where here are the three kind of moves I made that I'm especially proud of. That was us looking at the moves and then determining that those particular moves we found to be creative in their own right. And even the application, I'm not sure, would have been able to kind of pinpoint that had it played another million games. Had we not looked at them, they would have disappeared and we would have had no idea.
So does it matter if the AI doesn't know that it's being creative? Are you saying that it's the human that would designate something as creative or not?
What I'm saying is, I'm latching on to creating something new. That could be a random set of pixels, or that could be some theme of some image extracted from it and learned what that is, whatever you want to pick up on, and apply that to another set of images, and they're certainly new, as in they didn't exist before. I'm not so sure that I immediately latch on to a belief that they are now coming out of a creative system. And whenever we look at something and I want to apply some sort of creative attribute to it, many times I'm the one who applies the creative attribute, not the system itself. It's not that the system did 1 million images, and out of those 1 million images, I picked 4 that I think are particularly creative. It did not.
David, do you think it can be creative, or do you think that's just how we're perceiving it?
Well, I think creativity in so many ways probably comes from very many angles. At the same time, you may be able to classify it in many ways. It would appear that human creativity combines some unconscious processes, like that would be related to dreaming, and yet also some reasoned, motivated, conscious processes where you're having the observer self-aware, aware of oneself in a particular context, trying to achieve a particular goal, somehow feeling this desire to achieve a particular valuable output. And even if it's an unconscious desire, when you see it, you're like, wow, that's cool. I now suddenly I have this great leap. I can see this thing that has happened in in a broad new context that can change the world. So then consciousness seems to have many aspects too in the human mind, related not just to the prefrontal cortex. Yes, it involves the prefrontal cortex, but also the anterior cingulate sulcus and the phi, the system resonance and coordination. And all of these things may be related to human level creativity in the sense of the Hofstadter strange loopiness of creativity, that where he creates this beautiful argument about how all these kinds of loops are necessary for consciousness and creativity. Gödel, Escherbach, and Arturo Golden Braid, beautiful, beautiful book about the mysteries of creativity. Well, if it requires getting these physical systems in this particular configuration where you have a certain level of conscious observation, maybe that goes, beyond a basket weaver bird, which is, you could argue, would be creative, but not like a human. Or natural selection, Darwinian natural selection is kind of creative, but not like a human solving a problem like this. There are particular neural architectural features that are strongly correlated with human creativity and also the highest levels of human intellect. And that creativity combined with intellect is a powerful combination. That's where almost every act that we might consider to be genius would spring from, this set of architectural features. Well, we only see that occur one place in the universe that we know of, and that is the human being. Maybe an octopus is creative in some way or another that we don't understand fully. Certainly animals and creatures, our organisms, show signs of creativity. Well, if this is true, maybe what we need to do is look at whole organism architectures for artificial intelligence, where we start putting these things together. And we don't know if, maybe it requires quantum loop gravity and some kind of quantum computing like Penrose. We don't know, but if we put a toolkit together where we can start to experiment at this highest level, maybe the machines can be creative. We don't know until we play.
Right, well, that's a good cue. I think we will play for the first time. So Adam, could I get the first slide up, please? Adam's actually human, not AI. Right, so this is a game. Can AI be creative? Let's find out what you think. So next slide. Okay, so we've got two riddles, riddle A and riddle B. Riddle A, what's the difference between a pretty glove and a silent cat? One is a cute mitten, the other is a mute kitten. And riddle B, what geometric figure is like a lost parrot? A polygon. So if you've got Slido up, can you answer either A or B to which one you think of these was created by an AI? If you don't have Slido, we can do it the human way and you can stick your hand up in the air. So who thinks that A was created by an AI? Okay, and who thinks that B was? Right, and the answer, so most of you think, oh, it's changing. Oh, people can't decide. Live increasing. It's neck and neck, it's like a horse race. Oh, no, that can't be true. We can't have an actual 50-50 split. Goodness me, that's almost statistically impossible that we could have predicted that. Right, so that's brilliant. We don't know. Is it still changing? No, people changing their mind. Right, the answer is A was the riddle created by an AI. It was the Jape riddle generator, which was created by Binstead and Ritchie in the 1990s. Riddle B is one of my son's favorite maths jokes. Okay, brilliant. Right, we've got a few more of those coming up as we go through. What I wanted to move on to is a kind of thinking about the practical applications of AI creativity. So, Dennis, why might we want AI to be, or need AI to be creative?
I certainly believe, naively perhaps, that it's almost inevitable that we'll move into some software paradigm for where the kind of UIs we know today will disappear and we'll deal with a set of agents. We can talk about exactly how we'll deal with those agents, but I just can't see that not happen. And if we start to deal with these agents, I think there'll be suddenly a set of expectations from us as consumers to what they do for us, which is going to be different to what we expect our software applications to do for us today. And today it's very much question-answer systems, have some question to some piece of software, you provide some sort of answer or action, and I'm happy about that because otherwise it will take too long to do by hand or couldn't do it at all by hand. But in this new setting for where these machines will kind of cooperate or be part of a team, we will expect some level of, I'm not sure I'm bought into the idea of creativity, but certainly common sense is perhaps the best moniker I've been able to kind of apply to it. And we can certainly see that in our very finite universe of meeting scheduling, which is such a tiny part of the whole universe that it seems almost not worth attacking. But there you have 120 plus people trying to figure that out. But even in that tiny universe, there's expectations for where if I describe something in natural language, you can pick up not just on the words themselves, but behind the words, what I want you to do. Set something up with you next week, or set something up upon my return, which is not even a temporal expression. It's just you trying to say, I want to meet up with you, but I'm somewhere else, but I might come back, and when I do come back, we should meet up. And I think that level of common sense, that will just be expected for this kind of future, which I certainly imagine happening. And if we don't solve that, I think we might fail at it.
I wouldn't be at all surprised if we don't solve it, ever, in the general case. I mean, it's a sort of the general version of the frame problem. Now, some people say the frame problem has been solved for AI. It's nonsense, it hasn't. It has been solved for certain areas in maths and science, where you can, and engineering, where you can express the problem, clearly enough, and the possible outcomes and the possible faults clearly enough that you can handle with them, you can anticipate them and handle them. But in the general case, the frame problem raises, if you like, what I would call the issue of relevance, and what humans regard as relevant in any particular case, including your meeting's case, and can I get home afterwards at a reasonable time, and all that. I mean, that's really open-ended. And I think you have to be, a member of a certain culture to appreciate the sorts of things that are regarded as relevant in that culture. And I think you have to be someone who understands the human condition, who is a human being, for certain other sorts of relevance, to be understood and to matter. And I just don't think that those issues will be fundamentally solved by AI, despite all the hype that there is about it at the moment. I think it's really misconceived.
David, Dennis, sorry, go ahead.
Given I've made a 4.5-year-long bet on being able to solve some parts of it, I'm obviously heavily biased. But I certainly don't have any expectation, or I can't imagine some press release from our friends at Google at some point in the not too distant future that rhymes with, ta-da, we solved it. Whatever question you have, we'll have an answer to it, or whatever job you can describe, we'll be able to perform that job. That seems, and I think we're very much on the same page there, almost unrealistic to me. And certainly as an engineer, and I just can't even imagine the setup. Now, being able to carve out a small part of the universe and describe that in full so that you can navigate it certainly seems feasible, or that's the bet which I'm making here. The universe is large, though, and being able to describe all parts and how they're connected, again, brings me back to, I'm not sure I'm sold on that happening, but I can certainly imagine certain pockets here and there being elements that you can define. And if you really ask me about what we spent the most time on, which was defining this universe, and plenty of my entrepreneur friends will kind of work at Morgan Stanley, believe they need to be entrepreneurs, download TensorFlow on Friday, and think they can be up and running on Tuesday. As in, we spent years on end doing no code, just trying to describe a universe, which certainly I'm sure to you seems fairly simple, as in how many things can happen in the meeting scheduling universe. That seems somewhat definable. And for us, that's been a almost impossible task.
David, where do you stand? Are you Team Dennis or Team Maggie?
Well, I stand on the principle of aspiration, that we know that there's a vast body of mystery. We don't know how the human mind works or the human body. We don't know how many dimensions exist in the universe. We've got working theories for these things and some conjectures, reasonable conjectures about what may be solvable or not solvable and what tools might be required to solve these problems. However, if we assume that it can't be solved, then really the chance of solving these problems rapidly diminishes to zero. So if we assume that they can be solved, then we can start to ask these creative questions. How may it be solved? We do know that the human imagination seems to be limited, and it requires a lot of work, creative work, to unlock the mysteries that we have. So we don't have, surely doesn't seem like that we have, some kind of omniscient and omnipotent creativity. It might be that the universe can be more creative than us in some ways. And maybe as we're unlocking all of these mysteries of bioscience and physics, we can unlock some of the physical mysteries of the human mind and the human creativity. And what's interesting is that these kind of small cases and toy cases that have taken a lot of work to yield real results haven't plateaued. We haven't stopped. Now, that doesn't mean that we can solve the hard problems of transformational creativity or the hard problems of consciousness, but it is tantalizing. It teases us to keep trying, to keep questing, to unlock these mysteries, and maybe we will. We don't know when that would happen, and we can make arbitrary predictions tomorrow, 10 years, 100 years, never. But almost certainly, our understanding is too limited to accurately predict, which means that it is possible. It may be possible. It may be possible. And so then, if we use the power, like for me, I think of the power of creativity as not just the power of reasoning, not just the power of combinatorics, but the power of dreaming. And there's mystery there. We don't know how dreams work exactly. We sort of say, okay, deep dreaming and convolutional neural networks produces these beautiful results, but it's not the same as humans dreaming. And so we see these dreams in this theoretical science, which is kind of a philosophical exploration of science fiction. A lot of what happens in science fiction inspires the quest of scientists, but also even those scientists who aren't inspired by science fiction. They often have to come up with a novel model, a framework, this transformational leap. Where does that come from? This power of imagination. Well, that power applied to imagining the future, sometimes it seems almost precognition, prescient. I'm not saying that it's any kind of spookiness, any sort of not anything based on physics or math, but what I'm saying is the power of imagination to see something big. Well, in science fiction, we see these things like thinking creative machines, and those inspire us. And I am actually, my whole undertaking in life is taking all these different creative disciplines and putting them together to make these robots into physically embodied science fiction. Meaning, like, cinema is science fiction, video games can be science fiction, written word can be science fiction, right? Well, why not AI and robotics? We craft those things together, and it's, in a sense, it's real AI, as in, like, some of the state-of-the-art, state-of-the-technique algorithms and, glued together. It's a research platform. But then using them to create things like the Android portrait of Philip K. Dick, taking the corpora of his writing and training this with statistical machine learning, this natural language generator that can then create things in the style of Philip K. Dick. It's like a ghost, a living ghost of Philip K. Dick. People would sit and have a conversation. They would swear there was a ghost in that machine, but it really there wasn't. But it enlivened, perhaps, I hope, people to dream of a future where machines might be as creative, insightful as the genius of Philip K. Dick.
That's lovely because Philip K. Dick, of course, inspired my little test today because of the Voigtkamp test in Do Androids Dream of Electric Sheep. So could we get our poetry slide up? I don't have a dream for you, but I do have 2 poems for you. Speakers, you can see it down on the screen at your feet if you don't want to turn around. So I'm not going to read the poems in their entirety. It's quicker if you do that in your head. The first 2 lines. So poem A home transformed by the lightning, the balanced alcoves smother this insatiable earth of a planet Earth. Poem B, the night brings another distance, larks from the razzle about being, bombarded with each picture skip and something wonderfully frozen. So same question, which poem was written by an AI? Which poem was written by a human? So if you think that poem A was written by an AI, choose poem A. If you think that poem B was written by an AI, choose poem B. Those on Slido can do it. We can have some hands as well. Was poem A written by an AI? Okay, not so many. Was poem B written by an AI? Okay, overwhelming hands for poem B. Slido is in support as well, although poem A is creeping up, but that looks pretty conclusive and is entirely wrong. Poem B is in fact written by a colleague of mine in the Faculty of English at the University of Cambridge and is characteristic of the Cambridge School of Avant-Garde Poetry. Poem A was written by a computer program in 2010 designed by Duke University undergraduate Zachary Scholl and was submitted to the Duke Literary Journal, The Archive, who accepted it and published it. Zachary was so embarrassed for his poor literary editors that it was many years before he actually revealed to them that he was not the author of the poem, but in fact the AI was. Brilliant. Okay, we've got one more of those coming up, but before we do, Maggie, we've talked about, sort of in general, about how a creative AI might be useful in a kind of business sense. I'm curious about how it might function in a creative industries sense. So the Royal Society did a very interesting study of machine learning and found that the UK public was quite willing to accept AI in areas like medicine and insurance, but very disturbed by the idea that AI might produce music or poetry or literature or film. So Maggie, do you think that there's a benefit to AI moving into those realms, or do we need to preserve those as exclusively human?
Well, certainly not exclusively human. I mean, there are many people, well, many is perhaps over-egging the pudding. There are an increasing number of people who are professional computer artists, where they don't just use computers, you know, in the way that David Hockney does. I don't regard David Hockney, despite his recent work as a computer artist. He's just using computers to do stuff which, you know, he could have done otherwise. It's just easier to do it with the computer. But people like William Latham, Ernest Edmonds, John McCormack, people like that, they are all doing computer art which they could not have done, could not even have imagined without the computer. And they regard the results as aesthetically valuable. Now, I mean, you as an individual may or may not in any particular case, but that's the case with art anyway. So people who are, as I say, professionally engaged in the creative arts, certainly if they're involved with graphics or to a lesser extent, but still with music, then I think, yes, they are increasingly using AI and benefiting from it. Literature is another matter, whether we're talking about poems or whether we're talking about novels and, you know, prose texts of any length. That's far more difficult. It's far more challenging for various reasons, including the relevance issues I was talking about earlier. So natural language is a huge problem here. But don't forget that with a poem, even if it isn't a haiku, we're prepared to put a lot more of our own imagination into the interpretation, into giving it meaning, projecting meaning onto it, than we are with a piece of prose. So yes, they've got a place there, but that's a very interesting question. You know, how large that place will end up being.
I'm going to add a little dystopian tone to proceedings as we draw to the close. Are there any reasons why we might be worried about AI being creative? Or any areas where we really wouldn't want it to be? David?
Two areas that would concern me. One is in the area of weapons of mass persuasion and deep fakery. Deep fakes that wind up deluding people and decreasing the accessibility to the truth and freedom and opportunities for actualization, making us pawns in an increasingly sophisticated power game among corporations and national interests. And the second area of concern, well, first, I'd like to say that if we could get algorithms to be more creative in pursuit of truth, kind of this isn't ideal more than anything, but like weeding out, the kind of prejudice and bias out of data sets and algorithms is, in a sense, in a narrow sense, about pursuing more truth and getting noise out of the data. So there's a kind of arms race between those in pursuit of AI for truth and those in pursuit of AI for manipulation. The second way that may be even more concerning is the stuff of speculation and science fiction. Let us just imagine, though, that we could create a machine that is not just super intelligent, but super creative, able to outmaneuver humans in any game that we might play in our real world. And it doesn't require a universal scale creative intelligence. It just has to be smarter than people in some sense.
Okay,
and
if
it doesn't share our values, then it could be scary.
Right, I don't want to end on a totally scary note, so final slide, our picture slide. Adam is going to be up in a moment, I hope. Yeah, there we go. Okay, which one was created by an AI? Painting A or painting B? Slido and Hans, painting A? Okay, painting B? That's closer than our poems were. Slido's obviously taking a little bit more time. Okay. Well, you guys have ended on a high note. Painting B is indeed the one created by the AI. Painting A is actually Paul Gauguin's Tahiti and Picnics. I hope that has given you some creative food for thought. If you wish to meet the speakers afterwards, please congregate towards the back of the hall, and a lady or gentleman with a blue lollipop will take you down to the Meet the Speaker room. In the meantime, please thank my panelists for a wonderful discussion.